Okay, quiz preview for Trig Quiz number 2. Basketball player is standing outside on a sunny day. He's exactly 6 feet tall. If he casts a shadow that's 7.8 feet long, that's on the ground, people, not in the air. All right, so this is the picture. We're going to find the angle of elevation of the sun. Tangent of the angle x is equal to 6 over 7.8. You hit second tangent, inverse tangent of 6 divided by 7.8. And that's 37.6 degrees to the nearest tenth of a degree. The degrees on your answer. 2, from the top of the school depression. I don't know why you're on the top of the school, but that's what it says. No reason, Scott, do you have a question? Did I type something wrong? I did put 36, but it was 37.6. I don't know what happened. Let me check my calculator. Yes, I copied down my own answer wrong. That's the problem. Sorry. There we go. Thank you for correcting that. All right. If you're up there on the top of the building for whatever reason, sunning yourself, I don't know. Your car's down in the parking lot. And you spot it. Okay, it's an angle of depression of 41 degrees. That's off the horizontal. If your eyes are exactly 78 meters up, so the distance from here to here, whether you're standing, laying, sitting, whatever it is, 78 is the measurement in meters. You want to know how far away your car is from you. Well, you are here. Your car is here. So it would be the hypotenuse. Since you are so adept at your geometry skills and remember everything from that class, alternate interior angles are congruent if you have parallel lines. That was the parallel lines. Alternate interior angles are congruent. So that angle can be put here. And now we can look at this right triangle and opposite over hypotenuse, what we're doing. So that's going to be, bless you, the sine of 41 degrees is equal to 78 over x. Careful how you calculate that. It'll be 78 divided by the sine of 41. All right, I got 118.9. Did you? 118.9 meters. Number 3. The sides of a parallelogram have lengths of 18 and 27, and one angle is 38. Find the length of the longer diagonal. Use the law of the cosines. Law of cosines, not the cosines. Anyway, okay, so this one's often missed. Where is the angle that's 38 degrees in this figure as it's drawn? Here, or here, or here, or both? Or these? No. Okay. The littler ones. That's an acute angle. All right. One misconception back from geometry. I hope you remember that. The diagonals of a parallelogram do not bisect opposite angles. Right? They don't. So if you draw in the diagonal here, that does not cut the 38 in half. We want to find this. What is this? We got to get this angle right here, guys, if we're going to use law of cosines. We need to know this. So, back to the beginning. Based on the picture, if this is 38, now let's find the rest of the angles in that, or we'll find this angle. What's the relationship between these? Okay, they are supplementary because remember, if parallel lines, consecutive interior angles are supplementary. Okay, so with that idea, this is 142 degrees. That's what we're using the 38 for. We really don't need 38 on our picture. what I'm doing is I'm using the fact that that little angle was 38 to find that supplement to it. And now I'm going to draw in what I want to find. That's the length. The sides are 18 and 27 of the parallelogram. Okay, so we can do x squared is equal to adjacent side 18 squared plus adjacent side 27 squared, not degrees, minus 2 times 18 times 27 times the cosine of 142. Now, I've had some people forgetting to do the last step on the problem. Were you to type in all of this mess into your calculator, you will be getting 1,818.94. Yes? So we type that in. Okay. You have another step. I'm hoping that you would notice, because I had some people forget to unsquare, to take the square root. I'm hoping that you would notice that that is sincerely, well, quite a unreasonable answer for the diagonal of that parallelogram, right? Not reasonable whatsoever. So you got to take the square root, and that's approximately 42.6 feet. Okay. Number 4. Draw the angles in standard position. That would mean off the positive x-axis. So we're going to come around 265 degrees. You may want to remind yourself that 90 would be here, 180 is here. This would be 270. So I shouldn't be getting all the way there. So it would stop somewhere around here. And there's a picture of it. 7 pi over 4. You might say, well, how am I supposed to do that? Well, one way is to use your conversion factor. Okay. And then I'm going to show you something else. So I'm going to show you that right now. Pi over 4 would be the reference angle. 45 degrees is pi over 4. You want to get that memorized. 45 is pi over 4. Pi over 3 is 60, and pi over 6 is 30. Okay, now, if you were to convert this, well, let's just say 1 pi over 4 is 45, right? You don't have to write this down. Don't write this down at all. I'm just showing you something. 1 pi over 4. 2 pi over 4 would be pi over 2, would be 90. 3 pi over 4 would be there. 4 pi over 4 would be here. That at 180. 4 pi over 4, pi. 5 pi over 4 would be here. This is what we're going to be doing with the unit circle. 6 pi over 4 would be right down there. 7 pi over 4 is here. So you don't have to know this yet. I just wanted to get you a little preview of how we're going to figure out where things are in the future. Okay, so I wouldn't be converting it, let's just say, 2 degrees at this point once I learned this. So this angle is actually from here. Oopsie, I went too low. Okay, so it goes from the positive x-axis into the 4th quadrant halfway. Negative 280. Well, this would be negative 90, negative 180, negative 270. So it's going to land us in quadrant 1. And negative 2 pi over 3, let's say you went ahead and converted it, because I know that's probably what you did, because that's what we've learned so far. You would have canceled out your pi's, divide by 3, 60, the 100, negative 120. Okay, so which is in here. Which is the same as negative 2 pi over 3. Convert the following to either radians or degrees. If you're converting to radians, you need to, if it's in degrees, you're converting to radians, you need degrees on the bottom, so the conversion factor is pi over 180 degrees. You can do this on your calculator, or you could divide by 10 and then say, oh, I could cut these in half. That's going to be 7 pi over 9. Next one, multiply by pi over 180. I probably typed that one. I would type on my calculator 225 divided by 180. I'd hit math, enter. And I don't know what I hit because it sure didn't do what I wanted it to do. I hit apps instead of, oh brother. Math, enter, enter. Got too close to the wrong button. Now it doesn't like me doing anything. Okay, well, so I think I'll just look at my key because you guys have probably already got it written down and are moving on. I took forever. 225 divided by 180 reduced should be 5 pi over 4. Yes? Okay. 10. 3 pi over 4. Now we're converting from radians to degrees, so we want degrees on top. 180 degrees over pi is our conversion factor. Cancel out the pi's. 4 goes into 180. 45. 3 times 45, 135. Multiply by 180 over pi. Pi's cancel out. 3 goes into 180. 60 times 5 times 60, 300 degrees. Next part says give one positive and one negative coterminal angle for the following. Your answers must be in the form that the problem is in. So if it's in degrees, your two answers should be in degrees. If it's in radians, your two answers should be in radians. The way to do this is to take your degrees and add or subtract 360. If you add 360, you're going to get 605. If you subtract 360, you're going to get negative 115. Now, how do you do 780? Subtract 360. Well, now you got a positive angle, which is, I don't know, 420. That's a positive one, so that could be one of your answers. But then you need to do it again. And that's 60, so that could be one of your answers, but only one. And then you need to do it again, so you can finally get negative 300. So you keep on doing subtract 360 to get the negative angle. So one of your answers needs to be 420 or 60, and the other negative 300. Or you could have added, I guess, but it seems like a waste of time since you got to subtract anyway. You understand my point? Did some of you write probably 1040? All right. This one, 3 pi over 4, we need to add and subtract 2 pi. 2 pi is once around the units, the circle. So that's 2 pi radians is 360 degrees. So I'm adding or subtracting 2 pi. How you do that? You convert 2 pi to have a denominator of 4 by multiplying top and bottom by 4, which is 8 pi over 4. Then you say in your head, negative 3 pi plus 8 pi would be 5 pi, so 5 pi over 4. Negative 3 pi over 4 minus 8 pi over 4 would be negative 11 pi over 4. If you have degrees here, I'm just marking it wrong. It won't matter if they're even the right degrees because that's not what the answer needs to be in. I can tell that you, if you can do degrees by the other questions. I want to know if you can do radians. Okay, name the reference angle for the following. Same thing goes for these. If your reference angle, if you're given an angle that's in degrees, your answer will be in degrees. If you're given an answer that's a problem that is in radians, your answer needs to be in radians. 195. You might want to draw where it is. It's how much past 180? 15 degrees. The reference angle is 15 degrees, guys. The rule for this, if you land in quadrant 2, is to do theta minus 180. Thank you. I don't get it. Oh. Are we good? So 195 minus 180 is the 15 degrees. Okay, 110. 110 degrees is in quadrant 2. you need to know the reference angle, which is not the angle with the x-axis. It's not 20 degrees, guys. It has to be this angle. So you need to do 180 minus 110, and that would be 70 degrees. Okay, 348, you're going to be in quadrant 4, almost back to 360. So the rule is 360 minus theta. So 360 minus 348, 12 degrees for your reference angle. Okay, 18. 5 pi over 6. Where is 5 pi over 6? Now, if you want to think about it as degrees, that's okay. But your answer has to be in radians. The answer is pi over 6. And this one's pi over 4. Reference angles are never negative. Never. Do not give a negative answer. Okay, and you say, well, how did I know that? Well, this is just multiples of pi over 6. How many pi's over 6? It's 5 of them. Okay, so pi over 6 is actually a reference of 30. So if you converted that, 1 pi over 6, 2 pi over 6, wheel, 3 pi over 6, 4 pi over 6, 5 pi over 6. It's actually right there. I'm going to teach you how to find that and know where it is by your unit circle. Yes. Not really, no. I don't think it just says what's the reference angle. So I want you to know where it is, though. Okay, so if it says you have to, it didn't say though you had to give the angle. So I mean, it didn't say you had to draw it. So since that wasn't in the directions, I couldn't penalize you for not drawing it. I recommend you do because it's going to be beneficial, like Friday. We're gonna be learning how to figure that out Friday by the unit circle. So this one, negative 7 pi over 4, if you wanted to draw it, negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4 would actually be all the way in quadrant 1. So if you were asked to draw that, this was just a review to do it all again. That's every 45 degrees, and that was just 7 of them. 8 pi over 4 would be a full circle all the way around. So that's 2 pi. All right, if the minute hand of a clock is 7.5 inches long, how far did the end of the minute hand travel from 9 a.m. to 11 a.m.? You need theta in degrees, not degrees, must be in radians to use that formula. So we're going to be doing 7.5 times theta. We got to find out what theta is. So if you're on a clock and your minute hand has to go from 9, let's say it's 9 o'clock right now. That's the hour hand. Let me make it shorter so this makes sense. So some of you that haven't really spent much time with analog clocks might get it. That would be 9 o'clock, right? If you looked at the analog clock. How far does it have to go to get to 10? How far does the minute hand have to go? All the way around, and now we're at 10. Oops, the shorthand would be at 10 o'clock. And then, oopsie, 11, whatever. So it has to go twice around. Does that make sense? 2 times 360 is 720 degrees. Or you could just remember that if it has to go 2 times around, then 2 times 2 pi, which is 360 in radians, would be 4 pi radians. Or you could use your conversion factor, which is going to give you 4 pi radians. Right? However you think it. So we're going to need to do 7.5 times 4 pi. Where's the pi? There we go. Got 94.2. So the length of the arc is 94.2 inches. 21. The terminal side of theta in standard position contains the following point. Find the exact values for the 6 trigonometric functions. Negative 3, 2. That would be left 3 up 2. Sorry, negative 3, negative 2. I got to go down. Oopsie. Okay. -3, -2. Boy, you guys jumped on me right away. That was great. Okay, so this is your -3, this is your -2. If you didn't want to draw it, it's not like you have to, but this is where theta, you're going to be thinking of theta. It's not really theta. Theta goes from here to here, so this is actually the reference angle of theta. So to find the sine and cosine of theta, this is what we use, though. And we need to find r. So we know x is -3. We know y is -2. And r would be the square root of 3 squared plus 2 squared. There's no need in writing negative signs because you're going to square it. So that's r is the square root of 13. Okay. Ew, I don't like that I got to write so tiny a space. These aren't spaced out enough. Sine is y over r. So -2 over the square root of 13. Cosine, -3 over the square root of 13. And tangent would be -2 over 3, -3, which is 2/3, positive. Now I'm going to do the reciprocal functions. Negative square root of 13 over 2, negative square root of 13 over 3, and 3/2. Now I'm going to go back and rationalize the denominators that I did not yet. So I'd have to multiply top and bottom by the square root of 13, giving me -2 square roots of 13 over 13. And for cosine, it would be -3 square roots of 13 over 13. And that's how they got to be. No decimals. Anybody still need this? Pardon me? No. You need, which one? What's it say? CSC. That is cosecant. What about it? The radicals in the numerator. That's why I didn't rationalize these before I wrote those. But I don't have to do anything to those because there's not a radical in your basement. Okay, there's nothing to do to those. If you did this and then flip this over, then you'd have to, and it would be a mess. It would just be icky. Yes, Gwen. Something might be undefined. So if you're on a quadrantal, say you're here, -1, 0. You want to think, and r would be 1. So 0 over 1 would be y over r. That would be your sine. It would be 0. Your cosine would be -1. Your tangent would be y over x, so it would be 0. Your cotangent would be undefined. Okay. So yeah, if you got a 0 in there, you got to just see where it is. Y being, for, like the other one, there's different ones that are 0 if you're here. So then that would be still r is 1. So if it was at 270, the cosine at 270 is 0. The sine at 270 is -1. The tangent is undefined because it's y over x. That making, okay? Good thing to talk about. It doesn't exist, but I guess you could make one up. I have done that before in the past when I taught trigonometry class, which is literally just a course in trig. You're saying, like, if you put theta there and you put 0 there and -1 there and 1 there. Yeah, it's like making a triangle that doesn't exist. That's all. I'm just trying to make, writing down what x is, what y is, and what r is. 22, you're told that the tangent of an angle is positive. What is the terminal side of the angle? What are you limited to just one quadrant? Well, we did a mnemonic that said, yep, tangent's positive in quadrant 1 and 3. Now, why? Well, it says y, so tangent is y over x, okay, and if y and x are positive, I can't write, are both positive or both negative, then the tangent is positive. I don't know. I was just writing, talking or thinking as I was writing, so it was a little messy. Sorry. Does that? You don't have to have my exact words. It just has to have some kind of reason. You can show me it's y over x, and then positive over a positive equals a positive, and a negative over a negative. You know, just tell me why. Okay, find the area of a triangular shaped piece of land with sides of 60, 40, and 35. Well, it's not equilateral. It's not a right triangle. It's just a triangle. All right, so let's make mine only. Oh, that almost is a right triangle I made, but oh well, doesn't matter. When you do law of cosines to find an angle, you're going to want to find the biggest one, which will be opposite the biggest side. So I'll just call it A. Cosine of A is adjacent side, squared and added. 40 squared plus 35 squared minus 60 squared. All over 2 times the adjacent sides multiplied. All right, so then we go and type in the numerator. 40 squared plus 35 squared. So we have to do a step before we can actually find the area. I think I did this in class yesterday, didn't I? Oh, well, no, that's right. I didn't do any with you guys. You didn't ask me any of these. Okay, negative 775, and on the bottom, 2 times 40 times 35. And that's kind of big. All right, we know we got to take the second cosine because it's cosine of A that equals this. So I'm going to just do it right now. Second cosine, negative 775 divided by 2800. 106.1, I guess, degrees. Okay. Now, the area formula would be the half of the adjacent sides to the angle now, 40 times 35 times the sine of 106.1. And that's 675 point something. Is it 0.9? 0.5? Square meters. Need a label that will count off. Area, so it's square units. Okay, now's your chance to ask other questions. Yes, Hannah. Well, let me check if I have 829 open. $30? 38. Thank you. I did these in second hour, so I'll just start all over. Okay, if you know the tangent of theta is negative 2/3 and you're in quadrant 4. That would be your reference angle. Now, how would I label this triangle? What is tangent? It's y over x. So this would be positive or negative. So it would be negative 2. And the x part would be 3. Now you can find r. Oh, it says to find the exact values of the remaining 5 trigonometric functions of theta. So yeah, we got to find r. 3 squared plus 4 squared. That's the square root of 13. So now I can start writing them. Sine of theta is y over r, so negative 2 over the square root of 13. Cosine of theta, x over r, so 3 over the square root of 13. The cotangent of theta we get from just flipping over the tangent, negative 3 halves. Cosecant, oops, I need to rationalize that. I better move this over. I'm just going to go down. Cosecant theta would be negative square root of 13 over 2. Secant theta would be square root of 13 over 3. And then I need to rationalize the sine. It's negative 2 root 13 over 13. And the cosine, 3 root 13 over 13. Too much perfume in there. It's starting to bother me. When? That's the kind you were asking me about. Cosecant 180. So just think of a point on the terminal side of 180. I would do the simplest one possible, negative 1, 0. That gives me an x of negative 1, a y of 0. Cosecant is, well, it's the reciprocal of the sine, and the sine of theta, sine of 180 would be, well, it's y over r, so that would be 0 over 1. R is going to be 1, and that's 0. So what happens when you do 0 over 1? You get an answer of 0. Well, what's the reciprocal of 0? Or if you did r over y for cosecant, that's going to give you 1 over 0, which is undefined. If you leave 1 over 0, I will mark it wrong. That's not the answer. Okay? You need to simplify it to undefined. Just like if you write 0 over 1, I expect you to write the answer as 0. I literally take off something if you don't do that. Okay? You don't write 0 over 1 and then say that's done. It's the answer is 0 if you divide. And this means it is undefined. You just write undefined. You don't even have to write for me 1 over 0. Okay? Something else? I went over the entire quiz preview. I am not counting it in whether you did homework or not. I'm counting these book pages. You better have some of them done if you have any thoughts about possibly needing or wishing to retake this quiz, which was mentioned yesterday. Sure. Any example that you give me, what it means here is if the sine of theta says is greater than 0, it means it's positive. And this would mean the cosine is negative. Now, all of them are positive in quadrant 1. So it could have been, so that won't work. It could be quite all students. Sine is positive in this quadrant, but cosine's not. So that's why it's quadrant 2. Here, they'd both be negative. And here, the cosine is positive and the sine's negative. So it has to be quadrant 2. Now, any angle that you can tell me that's between 180 and 90 would be a satisfactory answer. That can literally be 179.9. Say that again. Oh, would that be an example? Oh, give an example of a negative angle. I didn't even write the right one here. Excuse me. I just totally wrote up one that's in quadrant 2. It needs to be a negative one, right? So it'd be negative 185 or something like that. I don't know. I guess second hour, I should probably say something to them tomorrow before because I accidentally wrote a positive one. Make sure it's a negative angle in quadrant 2. So over between negative 180 and negative 90. No, negative 270 would have to be up there, right? Better. Any something else? No, no. All right. Ellen, page 813. Well, it's the one I didn't. Wait a minute. Let me see if I have a smart of it. I don't. Darn it. I didn't make one. Okay, that's right. I'll just do it on this. What number, hon? Does it tell you, can you read it to me, or does it have like, yeah, please read it to me. Oh, okay. So it's going up at an angle of 20 degrees. Find the vertical distance. If it's horizontal distance is 60 feet. Okay, so opposite over adjacent. So that's just going to be the tangent of 20 equals x over 60. So 60 tan 20. Right triangle trig. At 21.8 feet. Eight 13, 46 feet. 28.6 feet. Do you want to do something with that one? No? All right. That's not horizontal. Horizontal lines go like that all the day. Sorry, except I should be straight like the ground. Vertical lines are this way. Eight what? 829.35. Sure. Cosine. All right, you should know cosine is x over r. That means x is negative 8. Sorry, I wrote x is negative 8. How do I know it's the x that's negative 8 and not the 17? It's the r. Yeah, it's r. R radius, it's never negative. Okay, so then you're going to find y. It's not time to go. Sit still. Y squared plus negative 8 squared equals 17 squared. So that's 64. This is 289. Subtract 64. Y squared is 225. You get y is 15. But you're in quadrant 3. So y is actually negative 15 because you're in quadrant 3. Both x and y are negative. So if you want to do sine now, it's going to be negative 15 over 17. So the cosecant is negative 17 over 15. I already got the cosine, so the secant is just the reciprocal, negative 17/8. Cotangent and tangent. You can stay where you are. Don't even get up. Oh, I'm not kidding. Cotangent, tangent is y over x, 15 over negative 15 over negative 8, so it'll be positive. And cotangent would be 8/15. Yes. And at page 813, the answer to number 35 is 25.3 feet.